Okay, guys, so this is going to be a pretty non-traditional way of me recording your lectures for you to watch as your homework portion. Reason being, with the measurement unit here, I really do want to be able to show you within the video tools within the lab that we've already looked at and how we can utilize them in our class. Just so you have another reference for them. So I'm going to be doing this with my document camera as opposed to a normal PowerPoint that I go through. Okay, so the first portion of our measurement unit is measuring length and the metric system. The metric system is best to be introduced, I feel, here in the very beginning because we will do conversions throughout the rest of the course. Okay, so the first thing we're going to focus on is length. Okay, we know that we can measure how long something is, and that's what length really turns out to be. Okay, so what does that mean? Length means we're measuring the distance, so how far from point A to point B we are away from something. Okay, how far did we go? We can also use length to measure dimensions, and so you can measure the sides of a cube. You could measure, if you have a cylinder cone, you could look at a pyramid. Some objects that we will eventually measure the length of the sides for in this class are these different 3D objects. We have two different cubes here. They are different colors. You can see that here. They're approximately the same size, but we'll use this in a later investigation. These two objects are of different size. Okay, you'll notice that they most likely have the same width here, but their height and their length you will see to be different. Okay, so we can use this in measuring length as well as dimensions. What are some great tools for doing that? We can use rulers. Okay, we can also use meter sticks, and so meter sticks, a lot of people still will commonly refer to these as a yardstick, and that's totally cool because as we've grown up, we probably haven't really done much with the metric system. We always focus everything on it is this many inches long. I jumped this inches high. In the track and field world, they measure the length of their races in the metric system in meters, but when we talk about throws for those field events or heights that people jump or lengths that people jump, they still go back to the English system that we'll talk about here. So they're going with both the metric system and the English system. Notice on rulers, and you've probably seen these before, and you've hopefully studied the metric system a little bit growing up in different science classes. This side of the ruler measures in inches. So you'll see from 0 to 12 inches. The other side, we can look from 0 to 30, and this is centimeters. Notice here, this is mm, and that means each tiny little dashed line is a millimeter. Okay, and we'll get further into that. So we have a bunch of different rulers in the classroom. We have wooden ones, some clear plastic ones, some other plastic ones, and again, we have the meter stick. Okay, we can also use tape measures. I don't have any metric tape measures in here. We do have some old-fashioned ones that measure in the English system that we more so use in physics. Okay, well, what is a standard unit of length? And it is a meter. Okay, very important to understand that it is a meter. The abbreviation for a meter, excuse me, is a lowercase m. Okay, a lowercase m. And that's pretty simple stuff to understand, right? Because we know length is long and distance comes from that. So let's look now at the metric system. Okay, metric system widely used in every country other than the United States. Okay, it is something that is based on the unit of 10. That is why in science we favor the metric system over everything else. Okay, the metric system versus the American system. We can also call this the English system. The metric system is more accurate and the metric system is easier to convert. What we're going to learn is that with the metric system, when we have to go from a larger unit to a smaller unit or a smaller unit to a larger unit, all we're doing is moving our decimal point, okay? Well, how do we do this? This is a nice little stair-step chart, and this is something that you may have seen in your other classes growing up. We like to put these in steps to help students understand that when you're at the top, you're at a higher position, so your value is larger. When you're at the bottom of the steps, your value is smaller, okay? And we could refer to this base as the landing, so we're kind of just in the middle, we're at 1. So anything that's above the base unit is larger than 1. Anything that is below the base unit is smaller than 1. Well, what is a base unit? A base unit is something that is just valued at 1. So we can have things such as grams, meters, liters. And these are all things that we will get into, what do they actually measure? So we use the meter here for length, right? A gram we will use with mass, and a liter we will also investigate with volume. So those are different portions of measurement that we will use within this class, okay? So let's take a look, okay? This is valued at 1. I'm going to go up to the largest, and then I'll come back to the base and go down to the smallest, okay? So when we move to the left, we're getting larger, okay? And when we move to the right, we're getting smaller. Deca, D-E-K-A, which is a prefix, and remember from your biology classes, a prefix is something that comes before another portion of the word. So this will go before one of these base values. So decagram, decameter, decaliter. Okay. The abbreviation is DA. Something that we can also see sometimes, places will use DK as an abbreviation for deca. I would prefer that you stick with this. If you use this, you're not technically wrong, because in some books, you will see this used as opposed to this. Okay. Hecto. Hecto is valued at 100. So the abbreviation for hecto is an H. Hecto. A little bit larger is kilo. Kilo is worth 1,000. If you've ever heard of a kilogram, it is 1,000 grams, okay? Notice how this just gets larger by 10, by a value of 10, okay? 10, 100, 1,000. We're adding a 0 every time we go up the steps, okay? Every time we go up the steps from 1, we're adding a 0. Well, if we said that when we go from the base down the steps, we're getting smaller, we're going to be adding a 0, but it would be on the other side of the decimal point, okay? So let's go back to the base, and we're going to go to deci. Deci has an abbreviation of a D, okay? Deci is worth 1/10. So I wrote this as a decimal because in science we do really prefer decimals, but I put them in fractions as well because sometimes to refresh people's minds about decimals, it's good to understand that you can pronounce it the exact same way that you do a fraction. So deci is worth 1/10 of whatever the base is. So if I have a decigram, it is 1/10 of a gram. This is smaller than my base, okay? Centi, its abbreviation is a C, or its symbol is a C, a lowercase c. And it is 1/100th, so 0.01. Then I have milli, 0.001, which is 1/1000th. Okay, its abbreviation is a lowercase m. I can say, I have 200 kilograms. How many grams do I have? Well, when you're doing problems like that and doing just metric conversions, you want to ask yourself 2 questions. And I wrote them down here, and I think this is one of the greatest things to do is get this written into your mind so that you can remember how to do these conversions. Ask yourself, how many places do I move? Okay, what do you mean, how many places? Well, think of this as like a board game, okay? Or you could say, how many steps do I have to move? Okay? To which direction? Am I going to the left or am I going to the right? Okay, so how many places? If I have 200 kilograms and I want to go to grams, okay, gram is my base. Kilo is up here. Treat this like a board game. I'm starting on kilo. I need to go to gram. 1, 2, 3. I'm moving 3 places. To which direction? I'm moving to the right, okay? So that means I'm going 3 places, and I'm just going to write this here. 3 to the right, or you could say 3 to the right, okay? That means I'm moving my decimal point that many places and to that direction. Notice 200 here doesn't naturally have a decimal point, so we always understand that as we put it after the last digit, okay? So in that sense, if I put my decimal point there, I'm going to move 3 places, 1, 2, 3, to the right. And this tells me that if I have 200 kilograms, I have 200,000 grams. Okay, we'll do more practice with this. Okay, how many places to which direction? Okay, well, let's compare the English system and the metric system. Okay, the English system and the metric system. We know that in the English system, 12 inches is the same as 1 foot. 3 feet equals 1 yard. 36 inches also equals 1 yard. And then in 1 mile, we have 5,280 feet. Those are pretty common things that we should all know, okay? In the metric system, we don't see all kinds of crazy numbers, 5,280 feet. We see some pretty simple ones that all are ones and zeros when we're making comparison just within the metric system, okay? I started out here just basing everything off of a meter, okay? For 1 meter, I have 1,000 millimeters. For 1 meter, I have 100 centimeters. For every 1 meter, I have 10 decimeters, okay? A decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. And a millimeter is 1/1000th of a millimeter, okay? For every 1 decameter, I have 10 meters because this has a value of 10, okay? If I have 1 hectometer, I have 100 meters. And if I have 1 kilometer or 1 kilometer, I have 1,000 meters, okay? Well, let's look at some comparisons that we may have to use in here to make some metric, English to metric conversions or metric to English conversions for length, okay? Take a look. 1 inch is approximately 2.54 centimeters. 1 meter is approximately 3.28 feet. 1 mile is 1.61 kilometers. 1 foot is approximately 0.3 meters. 1 yard is approximately 0.91 meters. 1 kilometer is approximately 0.62 miles. Do you see the difference here when we're doing these conversions from one system to another, how various the values are? And you can see that again here when you just look at some English units compared to metric units. Here it's all off of 10. Move your decimal point. Here we have to plug and chug in the calculator, okay? We will do work with dimensional analysis in class, so we will look at converting from one to another. So let's just do one practice one here, okay? If I have 1 kilometer, I want you to convert that into inches, okay? How many inches are in 1 kilometer, okay? When we do conversions, you have to show your work, okay? You have to show your work. And how do we do this? 1 kilometer, okay, is what I'm going to start out with. We assume that it is on top, okay, for our conversions. We have to take a look and say, hey, I don't see anything right here that directly takes me to the English system from the metrics, but we can look down here at the bottom to our conversions, okay? Let's find something with kilometers in it, okay? I can see that 1.61 kilometers is equal to 1 mile. And then we can go back and say, hey, yeah, we got some work here for a mile. So we can use that, okay? 1.61 kilometers is what we have in approximately 1 mile, okay? Why did I set it up this way? Take a look. Do I have a unit on top and a unit on bottom? Absolutely. Cross them out, okay? I know that I'm going towards what I want to have as my final unit, okay? Mile, let's look at the English system. I know that for every 1 mile, I have 5,280 feet. Okay, mile on top, mile on bottom, they cancel each other out. Okay, doing this, checking your units to make sure they're canceling out, helps you make sure that when you plug this into the calculator, you are going in the right direction. Okay, if I would have this flipped and put 5280 on the bottom and 1 on top, my answer is going to be very, very wrong. Okay, check your units. Okay, I can go from feet to inches. So let's go ahead and do that. 1 foot is 12 inches. Feet, feet. Do I want my answer to be in inches? Yep. So all you have to do then is plug this into the calculator. Okay, 5280 times 12 divided by 1.61. Okay, so you can see an answer here, which is pretty large. 39,354 inches. Okay, so a kilometer compared to inches, look, the numerical value is way larger because a kilometer is way larger than an inch. Okay, just a brief little look at doing some conversions. We will focus on those later in class.